asynchronous day, we assigned 1 through 16. I'd like to start with questions from homeworks. If anybody has any questions from worksheets 1 or 2 or 1 through 16, I'll happily answer that. Aiden.
I think it was like 16 with the basics.
From the problems, let's take a peek. Right there?
Yeah.
Sure thing. Oh, that's not what I want. This is what I was trying to do. Okay. So, here we have cosecant, inverse of negative 1.5. And we want to find that for theta between pi over 2 and 3 pi over 2. So what I'm going to do is I'm going to think about this as sine theta is negative 1.5. And I know that that's negative. So if I draw myself my picture, my angles are positive, so I'm going to be going counterclockwise. So 0, 1/2, 2/2, 3/2. So the interval says I have to be in quadrants 2 or 3. And then if I remember, sine, all silly turtles crawl, that has to be sine negative, so it has to be there in quadrants 3 and 4. So my answer must be here in quadrant 3. If I call this guy alpha between the terminal side and the x-axis, and I ask myself to write an equation that relates theta, pi, and alpha together, I would write, oh my goodness, I didn't mean sine there, I meant cosecant. Yikes. What equation relates theta, pi, and alpha together? Theta plus alpha is not what you want, because I noticed that theta is more or less than pi. It's more, right? Because it passes pi. How much more than pi?
Omega.
Alpha, right? So to get to theta, I had to do pi plus alpha, right? To here gets me to pi, and then alpha more gets me to theta. All right, so alpha should be cosecant inverse of the absolute value 1/2 or negative 1/2, or I'm sorry, 1.5. What's the problem though? Do you have a cosecant inverse button on your calculator? No. Ugh. So here's the trick. Cosecant is 1 over sine. And if I flip both sides of the equation, and say sine theta is negative, or is 1 over negative 1.5. And then if I put the sine inverse back, so alpha would be sine inverse, absolute value, and that's what I'm going to use there. And now it's just calculator time. So I have pi plus sine inverse. And I'm going to do the absolute value in my head. What's the absolute value of negative 1 over 1.5? Positive 1 over 1.5? Gee golly, Mr. Kulik. I know, I got all the brain busters today. So 3.87 should be my answer there. If I wanted to check that, I could do cosecant of that. So that's, again, 1 over sine. I get yes! And I should check to see if that's in between 1/2 a pi and 1.5 pi. Well, I know that this is less than, is like 1.57. This is like 4.6 something or another, 4.7. So right in the middle. I could type those in my calculator and get the decimals if I wanted to. Mr. Kulik knows him because he's been teaching math for like 15 years and has literally done these kinds of problems like thousands of times. And after a while, you just like memorize stuff because you just see it that many times. Well, like, what's that one movie that you've seen so many times, you know, like all the dialogue from? You guys don't have that? No? Oh, goodness. Get out of here. Aiden, does that feel okay? And again, the issue is probably going here to there, right? Is thinking to do that to where you can get the sine theta and get a value for alpha. Grace.
So like the absolute value, it would just like you like take out the negative.
I just do it in my head and take the negative off when I type it in my calculator. You can type an absolute value in your calculator. To do that, you press the math button and then you go over to the number tab and you pick the ABS command, but like that's a lot of buttons for just like taking a minus sign off something, you know? And I can get rid of the minus signs in my head. I don't need the calculator to do that for me. You know what I'm saying? So I just usually just do it in my head when I type in my calculator. You guys have a tendency to forget to do stuff like that. I would suggest for you guys maybe typing it into your calculator and just getting used to doing it until you're like, yeah, I remember to do the absolute value every single time. Because it's easy to look at one of my problems and see like I did the absolute value of 1 over 1.5, and I'll get the same answers if I did just without the absolute value if it was positive 1 over 1.5. So like it's one of those that's like easy to kind of overlook it because unless it was negative, you don't catch that there was anything wrong with your procedure. You know what I'm saying? So anyways. Others questions from homeworks. This is a good one though, just like a worksheet 2 problem. Miriam.
Can we have worksheet 2?
Yeah.
Can we do like 12
12 or
or something?
something. Yeah, or something. 12 works for me. Is that the one you really want to do?
It's kind of just like any one of them with like, where like you have to do like the quadrants, but like the number like.
12's a good one because it's got negatives in it. That's why I thought it was a good choice. All right, we'll start by drawing our picture. So I'm going to use my interval first. Notice that my angles are negative, so which way do I need to be counting? Clockwise. So 0, -1/2, -2/2, -3/2, -4/2, -5/2, -6/2. That's the start. -7/2, -8/2. So we're looking at quadrants 2 and 3, or 1 and 2. And then here we have tan theta is 1 or 12.95. I notice that's positive. What quadrants is tangent positive in? A and T, right? A for all sine, cosine, and tangent are positive, and T for tangent. So which one do I want? Quadrant 1. So if I draw my picture, remember I'm going clockwise, so I go -2 pi, and then before I can get to -4 pi, I have my end, so that's my theta. So my alpha, again, always between the terminal side and the x-axis. And now I'm going to relate my question, or relate theta, alpha, and -4 pi So I start by asking myself, is theta more or less than negative 4 pi? More, because negative 4 pi is more negative. Ugh. Okay, so how much less than theta is negative 4 pi? Alpha less, right? It's okay.
I have a question. And the reason you use negative 4
Because that's when I look at the angle formed by alpha, I'm looking at the part of the x-axis that forms alpha. So if, my thing was over here, then I would be using 3 pi. Or negative 3 pi, I mean. But. Okay, I think it's calculator time, right? So we have to add the alpha over, right? So negative 4 pi, and then we'll be plus tan inverse of the absolute value of 12.95. What's the absolute value of 12.95? The fact that there's no one responding to me before I could even finish. Come on, guys. We can do this in our heads. There we go. So 1107 looks like my answer there. Let's check real quick. So if I do tangent of 1107, what should I get? 1295. And 11.07 should be smaller than negative 3 pi. Definitely is. And bigger than negative 4 pi. Definitely is. I feel like I got the right answer. Miriam.
So I didn't do my graph right at all, but I still got the right answer.
Okay.
Are you maybe looking for graphs already?
Yup. Ask a question and think about whether you really want the answer to that or
I
not.
don't think the graphs were required.
You should provide evidence as to how you did the problem.
Okay.
Because I'm going to be concerned about whether the procedure you used was lucky or correct.
Okay.
Because you can just to some extent kind of guess and check the thing.
Well, if
I can just do tan inverse of 12.95 and just keep subtracting stuff and guessing at subtract 4 pi, subtract 3 pi, add 3 pi, and then make it negative, add 4 pi, you can try a bunch of stuff and probably get to the right answer.
Well, I wrote out the equation and I did the subtraction and all that. But if I saw I did it wrong and I got a negative number, I would go in and change my sign.
Okay. Doesn't have to be perfect, maybe, but it should be pretty close. Should be clear as to how you got to the answer. That's what I'll say. Okay. Does that feel okay?
Do we need to put the alpha and the theta sign on the graph?
I usually do, but if you have the picture drawn correctly, I don't think it needs to be labeled per se, but you need the spiral on there.
Okay.
To tell me what is theta. Is that okay? All right, you guys ready to go ahead to the new stuff? Very little new stuff today. It's our last day in 4-1. Bye 4-1. It's been nice snowing ya. And we're just going to look at no new content today. We're just going to look at 2 more kinds of problems. That sound okay to you guys? Sure, whatever. I want to recall something that we're going to use today in the problems, and it's the ranges for these inverse functions. So remember we had talked about cosine or sine inverse, cosine inverse, and tangent inverse, right? The ranges on sine inverse goes from negative pi over 2 to positive pi over 2. The range for cosine inverse goes from 0 to 2 pi. And the range for tan inverse goes from negative pi over 2 to positive pi over 2. Sure. Yeah, I would probably remember that for my note card. When do I really use these? If I'm not provided an interval to find my theta in an interval with the problem, right? So like on worksheet 1 and 2, we gave you an interval over which we're solving on each of those. Right? If I give you no interval, then the interval you're using should just be this. So let's look at a couple of examples here. Let's say we would do cosine inverse of tangent of 45 degrees. So like in most math situations, I'm going to start with like the inside out, right? So I'm going to look at tan of 45. When you see 45 degrees, what do you recognize? That's a unit circle angle. So I'm going to go to my unit circle. Unless you have it memorized by now. Does anybody have it memorized from using it so much? Give it time. If you have aspirations of taking AP Calculus at some point, or taking a calculus class at some point, it would be a good idea to do that. All right, so here's my unit circle. I'm going to locate 45 degrees. And then we're doing tangent of 45, right? What is tangent on the unit circle? Y over x. If you know the answer, say it loud and proud so everybody can marvel at how smart you are. Anybody want to re-go on who said it so loud? Somebody whispered it really nicely, quietly. I think it was Lexi, but I'm not sure. No. Okay. Came from that direction. Not anymore. Sorry, Lexi. So the y is root 2 over 2. The x is root 2 over 2. So what do I get when I divide those two numbers? It's taking entirely too long. What? 1! Loud and proud, right? Root 2 over 2 divided by root 2 over 2 should be 1 because they are just the same number, right? So what do we have now? We have cosine inverse of 1. On the unit circle, what is cosine? X. Thank you, Grace. So I'm going to go to the unit circle and look for where x is 1. Over where? Over what interval? Because it's cosine, I'm going to be looking at from 0 to 1. Or 0 to pi, excuse me. Everybody's okay? So I go over to my unit circle. 0 to pi is here. I'm looking for where x is 1, right there, 0. Should I be answering this in degrees or radians? What do you think? Degrees, I agree. Why? Yeah, excellent. So in general, you'll give your answer in whatever angle measure the problem is given in, unless otherwise specified by the directions. But since we're starting in degrees, we should give our answer in degrees. If the problem said, though, give your answer in radians, then you should give your answer in radians even if it starts with degrees. That's okay. Everybody's good? So far, so good? NBD, right? Just like a worksheet 1 problem with a little extra, like, oh no, I had to look up what was going on inside of the thing. What did it do, though? All right, let's do another. Whoa, hold up. Hold the phones, Mr. Kulik. What in the devil is arctan? Arc is the same thing as like the inverses. So just a different notation. I forgot to mention it earlier. But arctan is tan inverse. Arc sine is sine inverse. Arc cosine is cosine inverse. I know. Why do we have 2 names for things? I mean, we have all kinds of English words that mean the same thing and they're different. Like, what's the problem, right? It's all the time in life. It's the difference between good and great. I don't know. It's the same thing. All right. Feel okay? So far, so good? All right, where do we start? Inside. Two pi over 3, is that a unit circle angle? Shoot, Mr. Kulik, I don't know. Well, let's check then. Let's see. Oh, I see it right there. And we're doing tangent of 2 pi over 3, so I need y over x. So far, so good? You guys feel good? No problems? Now, you could reduce this. I, though, am not going to. Why? Because I'm doing an inverse trig function to this. So I want to know what x and y were, right? So I'm going to be looking for tan inverse of negative root 2 or root 3 over 2 divided by 1 over 2 on the interval from negative pi over 2 to positive pi over 2. Well, I remember that tangent is y over x. So I'm going to be looking for when y is negative root 3 over 2 and x is positive 1/2, or when y is positive root 3 over 2 and x is equal to negative 1/2. Remember, if a fraction is negative, it means that either the numerator could have been negative or the denominator could be negative. Everybody's okay with that? So let's go to our unit circle. Negative pi over 2 to positive pi over 2 is what part of our unit circle? What quadrants? Negative pi over 2 to positive pi over 2. 1 and 4 is correct. So I'm going to look for either where x is positive 1/2 and y is negative 1/2, or where x is negative 1/2 and pi is positive root 3 over 2. Well, I know that x can't be negative in quadrants 1 and 4, so I have to be looking for the spot where x is positive 1/2 and y is negative root 3 over 2. So that's 5 pi over 3. Are you okay with that? Grace?
Wait, how did you get on the right side?
The yellow circle?
Yeah.
From negative pi over 2 to positive pi over 2. So 0 to pi over 2 is there. 0 to negative pi over 2 is there. So that's quadrants 1 and 2, or 1 and 4. Ugh. Is that okay?
Yeah.
All right. Are we done? What do you guys think? No. What's wrong with this answer? It's not inside our interval. Rats! Is it too big or too small? Too big. Good. What should I do to make it smaller? Subtract 2 pi. Great. To subtract 2 pi from 5 pi over 3, what do I need to have? Great, a common denominator. What would that common denominator be? Yeah, the common denominator would be 3. So if I subtract these two fractions, 5 pi minus 6 pi is negative 1 pi, and the denominator should just be 3. That guy there is in between negative pi over 2 and positive pi over 2, because a third is less than a half. So negative a third is more than negative a half. What do you guys think on these ones? It's all right, right? Just basically a worksheet 1 problem with an extra, like, you have to figure out what goes inside the worksheet 1 problem, but it's not much different than that. The second type of problem that we're going to ask you to do is a little bit different, but still kind of the same idea, using the same ideas. Says, find an algebraic expression equivalent to sine of arc cosine of 2x. So when we say algebraic expression, what are we talking about here? It says, find an algebraic expression. What would be an algebraic expression? What do we mean by that? What? Well, an expression is different than an equation because an equation has an equal sign. But what are they both going to have? An expression and an equation, possibly. A variable. Just saying that your answer is probably going to have x's in it. That's all. Everybody okay with that? So instead of your answer being like 1/2 or something like you're used to, it might have x's in it. Is that okay? All right. So just like usual, we're going to start from the inside out. But I want to slow down a second. So when we calculate like cosine inverse of something, like arc cosine, what kind of number are we getting back? What is that number telling us? If you do sine inverse or cosine inverse or tangent inverse, what is the number you're getting back from those problems? What is that number? What type of quantity is that? It's an angle measure, right? Whether that angle's in degrees or radians. So what I'm getting back here is just some angle. I'm going to call that angle theta. So far, so good? So I'm just going to think about the insides as theta equals cosine inverse of 2x. which is the same thing as just saying cosine theta needs to equal 2x. Now, one of our definitions for sine, cosine, and tangent was a right triangle, right? That's the definition we're going to use to do these types of problems. In a right triangle, how do we calculate cosine? Yeah, adjacent over hypotenuse. So I'm going to think about 2x as 2x over 1. So what should the adjacent side be? (2x). What should the hypotenuse be? 1. How am I going to find that third side? Pythagorean theorem. For the time being, let's call just that side y. So when I apply the Pythagorean theorem, what's the one side I have to be careful about where it goes in the formula? It's the hypotenuse. Where does the hypotenuse have to go in the Pythagorean theorem? Has to be C. So a squared plus b squared equals c squared. So far, so good? All right, quantity 2x squared, what is that? If I simplify that down. Oh, guys. 2x times 2x. 4x squared, right? Y squared is just y squared. What's 1 squared? 1. So far, so good? I'm going to get y by itself, so I'll subtract 4x squared from both sides. And then to get just y, what am I going to have to do? Square root both sides. When I square root both sides of an equation, what do I need? Plus or minus. Good. Now, wait 1 second here, though, Mr. Kulik. What is y representing? A side length for a triangle, right? An unknown side length for a triangle. Should that be plus or minus? No. Can triangles have negative side lengths? No. So we'll discard the plus or minus. We'll do that every time on problems like these because we're always going to be resolving this into a side length of a triangle. Oh, so that's an interesting question. So Jacob, you're asking, could I do that? That's what you're asking, right? What do you think? Can we do this? Who says yes? Who says no? Who's too scared to even venture a guess? All the rest of you chickens, start clucking. The answer here is no! You can't do this. So, in general, x or radicals do not distribute. In fact, the only operations that you know about at this moment that distribute across addition and subtraction, there's 2 of them, multiplication and division. Radicals don't distribute. Exponents don't distribute. Sine, cosine, tangent don't distribute. Logarithms don't distribute. Nothing you've seen other than multiplication, division distributes across addition, subtraction. If you take calculus, you'll see two new operations that can distribute, but that's a long ways from that. So no, the answer is we can't do that. So that side should just be square root of 1 minus 4x squared. Everybody okay? All right, let's recap where we're at now. So if I look at the original problem, that's really the same thing as just saying sine theta, right? Well, in a right triangle, like I've drawn here, how do I find sine theta? Opposite over hypotenuse. So what's the opposite side in my right triangle? Well, we'll write it in terms of x. Square root 1 minus 4x squared. And what is y? Or I'm sorry, the hypotenuse. 1. So if I reduce that, just the square root of 1 minus 4x squared. Overview. What are we doing on this problem? We're taking the inside expression to build a right triangle. We'll probably have to use the Pythagorean theorem to solve for the third side length in terms of x. And then we use our right triangle to evaluate the outside part. Just using right triangle trig. Everybody's good? Should we do that one more time? Okay. Your guys' practice on this is going to be worksheet 4. Let's just do the first problem from worksheet 4 as an additional piece of practice. That way everybody has one part of the homework done already. Cool, Mr. Kulik? Yes, sure. All right, so what do we do? The inside stuff we call theta. So theta is cosecant inverse of x, right? That's the same thing as saying cosecant theta is equal to x. Cosecant is 1 over sine. So if I want to get just sine, I can flip both sides. And in a right triangle, what is sine? Opposite over hypotenuse. So draw my picture here. There's my theta. The opposite is 1. Hypotenuse is x. And then let's find our side y in terms of x's. So 1 squared plus y squared equals x squared. Subtract 1 from both sides. Square root both sides. Ignoring the plus or minus because what we're calculating is a length. So far, so good. And then if I want to do cosine theta then, that's adjacent over hypotenuse, which would be root x squared minus 1 over x. And once you're good at them, they're like a 30-second problem. They won't be 30 seconds right away, right? But by the time you get to problem like 6 or 7 or 8 or here towards the end, they should be quite quick. Yes, Miriam.
Do you need our calculator for like any of these?
No! You do not need a calculator to do any of these. Okay? That's part one of what I'm going to ask you to do today when I'm done talking, which is pretty much right now. Part two, I also have a Delta Math assignment for you. I know, I'm excited about it.
Kill me.
Let me just log in real quick so I can show you about it. Okay. 8th hour. So if you go into your Delta Math, you're going to see the Chapter 4 Delta Math. And there's just 2 questions.
Oh, only 2 questions?
But they're a little bit differently formatted. So let's look at it. The first one says quadrants of trig functions. Notice this is a timed problem. So you're going to have 100 seconds to get 15 correct responses in a row. So let's see what this looks like. Determine the possible quadrants of theta in which theta could lie. Cotangent is negative. So that should be quadrants 2 and 4. Cosecant is positive. That should be quadrants 1 and 2. Cotangent is positive. That should be 1 and 3. Cotangent negative. Oh no, I pressed the wrong thing. What happened? Stop my time, stop my score count, and now I have to start over again.
Oh, we get multiple tries.
You have to keep doing it until you get your 15 in a row. Okay? Stay with me, guys. Second question says combine radian angles. Also timed, also 100 seconds, also 15 in a row for completion. We hit start. Pi over 6 minus pi. Negative 5 pi over 6. Pi over 4 minus pi. Negative 3 pi over 4. 1 pi minus 2/3 pi. That's 1/3 pi. 1/6 pi minus pi is negative 5/6 pi. 5 pi plus 3 pi, 7 pi. Oh no, I got it wrong. What happens? Time stops, count stops, and you have to start over again. Everybody okay with what the Delta Math looks like? Just 2 questions. Will you have to try these more than once? Almost assuredly. We might have to try them 10 or 15 times before you get your 15 in a row. Maybe. Is it just good practice? Yes. Okay. The third thing I'm going to ask you to do, so if we look at our My Notre Dame and we look at our class page, if you scroll down to the bottom under announcements and click on this surveys, there's a list of 12 links. These links will take you to a Google form in which a student is asking you to complete some survey questions. None of the surveys contain more than 2 or 3 questions. If you've already completed these surveys in your CT, I say thank you already. If you have not yet, I would ask you to do that. If you complete all 12 of them, I'll give you 1% extra credit on the next test. If your entire class completes all 12 of them, I'll give everyone 2%. I did.
So I've just already done all of them.
Then you don't have to do anything new.
Okay.
If you've already done it with your CT, then I don't need you to do anything else on this. But if you haven't, I need you to do this. I'm going to be checking by next class to see if everyone's done all 12 of these surveys. That counts even for the people that may be absent or in the bathroom or sleeping. So make sure, if you would like 2% instead of 1%, that you nag all of your friends to make sure they fill out the surveys honestly and completely. You can do that now if you'd like to do that now while you're thinking about it so you don't forget. Kate. Of course. Everybody feel okay about what I'm asking you to do? Surveys. Delta Math, Worksheet 4. Any of the above, or potentially 1 through 16 if you didn't complete that on the asynchronous day. Shame on you if you didn't. Everybody happy with what to do? I'm going to stop talking and let you get to it, okay?